Hi everyone, welcome to the demonstration of my embedded system project on the air warning medical device. In this video, I will first introduce all the components used, along with a brief description of each one, and then move on to the practical phase with several tests. First of all, the Atmel ATC52 microcontroller, as you can see, is used as a central component of the air warning medical device. This microcontroller is completed by an oscillator and a reset circuit block, as you can see, with crystal, capacitor, resistor, and cap-elect components. Then, for the other components, there is the helium-35 temperature sensor and analog to digital converter, as you can see. The helium-35 component is used here to set the temperature manually when the air warning medical device is in operation. It was chosen because it allows to control temperature precisely, and the ADC0802 component is also used to convert analog values into digital values and to answer data transmission to the microcontroller. Next, to simulate the operation of the air blower and heating elements, a stepper motor, as you can see, was chosen into a Proteus simulation. Its role is to illustrate the stages when the air warning medical device is activated. Due to high voltage and current limitations, the stepper motor is interfaced through a HIL 293D motor driver, as you can see. Then the assignment requires displaying this information to the other during operation to guarantee the transmission of information on temperature and operating time. This is accomplished in the design through two methods. The first one is remote access using a PC through serial communication, and the second one is local access via an LCD screen. For the virtual monitor, as you can see, this setup involves two connections. One for receiving data and another for transmitting data. It allows the system not only to send values to the PC, but also to be fully controlled using command keys. For the LCD screen, as you can see, the module features 14 pins, 8 of which serve as data pins, but however, only 4 data pins are used in this design to conserve microcontroller pins. Finally, the assignment requires to inform the user when the temperature exceeds the selected maximum temperature. This is accomplished in the design through two objects. The first one is by the LED and the second one is by the buzzer, as you can see. The LED is in color red because it is the most appropriate method for visually alerting that the temperature has been exceeded. Its bright and universally recognized warning color ensures immediate attention. The buzzer, on the other hand, has been included in the circuit to assist visually impaired or blind individuals by providing an audible alert to signal the problem. So let's move on to the practical implementation. I start the simulation by pressing the triangle upon activation, as expected. Upon activation, as expected, a pop-up window from the virtual monitor opens, prompting me to select a temperature and a duration. Additionally, the LCD screen displays both the temperature and the timer. I will randomly choose the temperature of 31.5 degrees and a duration of 1 minute. 1 minute. Once the final value is entered, the air warning medical device begins its operation. This. Now that you have entered the last value, the motor which represents the air blower and the heating element starts functioning, as you can see. The timer also begins counting down, as you can see. Next, let's try adjusting the temperature by increasing it. On the LCD, the temperature updates correctly to the new value, like this. It's bugged a little bit. Let's then attempt to set a temperature above 31.5 degrees. As observed, both the LED and the buzzer activate, and the message appears prompting me to lower the temperature. I reduce the temperature and the LED and buzzer turn off. However, the motor continues to operate. Oh, let's now wait. At the end of this program, I will now select different values. This time I will and the message appear prompting me to lower the temperature. Yes. Nice. I remove this. This time I will set the temperature to 38.5 degrees and the duration of 4 minutes. The changes are correctly reflected to the LCD screen, as you can see. Next, I will adjust the temperature to a value above 38.5 degrees. And it works perfectly. Finally, I stop the operation of the air warning medical device. I will press this push button and the program stops as expected. And that's it. This is the end of the video. This project has been a great challenge for me. I hope you enjoy it and see you soon. Goodbye.